Okay, so let's take our case study of FASTQ file processing and convert it into a module so that we can use it over, we can use the same module over and over again as opposed to writing a function and then copying and pasting the function every time you need to modify or work with the FASTQ file. And actually, before I do that, I'm going to switch over to Atom here. And before I even do that, I'm going to actually write a quick hello world for modules, just so I can show you every single aspect of a module, how the files are used and how you can see the py.c file when it's compiled and so on and so forth. In fact, actually, I've already written the FASTQ module, so we're going to do a quick hello world example first, and then I'm going to review the code itself. So I'm going to write a function here. We're going to call this function, actually just call it function1, right? And this is just going to say print hello world first module example, right? And that's it. We're just going to call this, and I'm going to actually save this into this my first project, what we first started with in here, and we're going to work within this instead of the root directory outside. So I'm going to call this module1.py, right? And then I'm going to write a new file. I'm going to switch down here to Python, and we're going to say import. We're going to import our module1, and then we're going to just say module1 dot function1. And before actually when I do that, I'm going to say in main file, right? Okay, so we're in the main file here. Then we're going to call our function, our module, and the method within the module, which is our function1. And we're going to save this in the same location where we saved our module. So come back to my first module. Here's my mod1. I'm going to say module underscore main.py, right? So notice both the files were .py. They're both saved in the same location, and if you're still looking at the screen, they are right here. Both of them are stored here. And now if I run, well, I'm just going to run first off the mod main program, which actually calls module1. So if I run this, sure enough, we have our print statement, which is in main file, which is right here. And then we called our module, and then the method within the module, which was function1, and it said first module example, and that got printed. Now notice we come back here to our file explorer. We have a mod1.py.c file, which is now actually a bytecode. So, well, you can't understand some of this stuff here. Some of it's plain English, some of it is not. But nonetheless, so since my mod1.py, which is being imported into my main function or the main file, is in the same directory, it found it, it imported the module, then it compiled the module and ran the module along with running the main file, and we have the output. Now, as I was telling you earlier, that we could actually only use the compiled bytecode. We don't need the source code if you are distributing this. So I am actually going to delete this. I'm going to go to mod1.py, and we're going to delete this file. All right. Good. And that file is deleted. Now, if I run this, well, there's no mod1.py, but we have a mod1.pyc file, which is the compiled version of our Perl script, so this should actually work. And if I close this out just to show you, and I'm going to write another print statement here. Complete example of mod1.pyc, right? And if I run this, it still runs. There are no error messages, no nothing. Everything works exactly as expected. We run the file. This time around, we actually don't need to compile, because when we said import, we found the .pyc, which is within our current file system or current file directory. So it found it. We don't need to compile it because, well, we don't have the source code, so it just works off the compile code, and the compile code said that. So I hope that makes sense. This brings it back full circle, as opposed to full circle in terms of how the import works, where the files are found, how the compile process works, and you can simply distribute the compile code as opposed to distributing your source file in case you didn't want to make your code open source. All right, now let's take a look at our FASTQ module, or the case study, right? So what are the basics of a FASTQ file? Let's start from there. First line is the sequence ID, right? And the sequence ID always starts with an ampersand. Actually, I'm just going to open this file that I have here. pqr sample.fastq. Okay, so I have two files, or two sequences in here, right? Line 1 always starts with a sequence ID. So the sequence ID starts with an ampersand, or at the rate sign, followed by a sequence ID, and the sequence ID is everything between the at and the first space. Anything after this first space here is considered additional sequence information. Right? The next line is always going to be your sequence itself, then the third line, which always starts with a plus, and then there will be some information, if any. And then the fourth line is always going to be your quality score, which is going to be in some sort of an ASCII unit based on what sort of sequencer you use. It is in FRET33, FRET64, and so on and so forth. And then the whole process repeats for every single sequence. So we want to read this file in every time and then process it somehow, right? So here is my FASTQ module that I wrote. And actually, I don't need to use this import statement, so I'm going to remove them. All right, so the base of this FASTQ file is just a function that says read FASTQ. It expects a file name to be passed in. Now I can I'm using that file to open the file, and I use a file handler as my variable. Then I've declared some initialization variables. I read the file. And then I'm stripping the end of line character here from the file, or from the line every time I read in. I use the counter to keep a count of where I am in my file. So whether I'm reading the first line, the second line, the third line, or the fourth line of my sequence. And I'm gonna say if I'm reading the first line, well, we know two things about it. Well, we know that the sequence ID part is just everything up to the first space, right? So I'm actually breaking up my first line, splitting them up by spaces here. So I split them up by space, and then I take the sequence ID to be everything from this variable bit of 0. So bit of 0 is going to be everything up to this part here. Bit of 1, 2, 3, everything else is going to be after that. That's the additional information. So bit of 0 is my sequence ID along with the at the rate sign, and I don't want the at the rate sign, I just want the sequence ID. So I said everything from 1 on over. My sequence header becomes everything that's in the bit after the first index point. So everything from second on over, take everything, join it by space, and that becomes my sequence header. And if I'm reading my second line, then it's just the sequence. The third line is the extra bit. The fourth line is the quality. When I read the fourth line, I'm also resetting the counter, so when I come back around, I start the process again. When I've done reading my fourth line, I am actually going to put the entire sequence into this sequence ID dictionary here. Actually, this is supposed to be one tabbed over. right? So when I read my fourth line, when I read my quality line, I know I've read everything that is related to this particular sequence. So now I'm going to actually write this into a dictionary. My dictionary's key is always a sequence ID, and then I add a second level of a dictionary here. So it's a dictionary of a dictionary. Within that, I have my sequence ID, the header, the quality score, the extra bit, and the sequence itself. So now I can use all of this information to recreate my FASTQ file or process my FASTQ file how I choose to do so, right? And that's it. That's when at the end I return the dictionary that I created in this particular module. So that's the simple process of how I read the file, how I read a FASTQ file and break it up into individual bits and create a dictionary. Now, how do we use it? Similar to our Hello World example, I import my FASTQ file. So I just say import FASTQ. And then we're going to say FASTQ.read FASTQ, which is the read FASTQ is our method within the import function. And since it expects a file name, I'm passing in that sample.FASTQ file name. Now the return is a dictionary, so I'm going to actually store it as a variable D. And then just for now, I'm going to show you just this, right? So D.keys will give me all the keys that are available in the dictionary, and then we're going to print out our dictionary. So when I print, there it is, right? The sequence ID. Whoops, I didn't mean to do that, sorry. So my dictionary keys are actually sequence IDs, which are going to be guaranteed to be unique for every sequence and then a file, so I know I'm reading in every single file. So there it is. Now, what if I wanted to process, right? What if I wanted to get to individual pieces of my each sequence? So I can say if I print dictionary.key, or sorry, K, this will actually show you, whoops, my dictionary of a dictionary, right? So each key holds another dictionary which has various values such as sequence ID, the extra bit, the sequence header, the sequence itself, and so on and so forth. So I can say D of key of sequence ID, and if I run that, it just prints the sequence ID, which is the same as the K value. But I can say sequence underscore header, and that prints all the header information that I have. I can say just the sequence, and that will print each sequence that I have available for every single key. I can say qual, and that prints out the quality score. So there you get it, right? I have created a module. Now every time I want to process a FASTQ file, I can simply import this module into my main file, pass in the FASTQ file that I want to, and then keep on processing the FASTQ file how I need it. This is way easier than having to copy this piece of, this logic bit where I open the file and save into a dictionary every time I want to process the FASTQ file. It's much more abstract. My end user or whoever's using it doesn't need to know anything about any of that, how the data is read in and stored. They just need to know that I can simply access every single bit of my FASTQ file using my dictionary indexing. All right, so I hope that makes sense. And next up, actually, before we finish up, when we started, we said, okay, so I hope that is clear on how we write modules and how we use modules. Now note that in either case, we for our module itself, we just started with this def function and return something. There's no other statements in here. Well, you could actually have more information here. You could have print statements here. You can do other variable assignment within your module, and all of that would be valid. It just meant for these examples, I just needed a simple definition or a simple function here and nothing else. You can also have multiple functions within your, or multiple definitions or multiple functions within your module. Let me go back here real fast to our module 1. Well, we don't have that anymore. So I'm going to recreate this. I'm going to delete this py file. Let's say delete, move to trash, and we're going to recreate a new one here, right? I'm going to say define function 1, or let's say mod underscore function 1, and we're going to say print in func function 1 of module. We're going to copy this a couple of times here, and that's Atom trying to reformat itself. Okay, so I want to call this function 1, 2, 3, and we're going to say print in main body of module. All right, and print. We're going to save this as inside my directory, which is my first object, and I'm going to say mod1.py. All right, so I've saved this. I'm going to have to change my mod1.main a little bit. Well, I think I deleted everything here, huh? Oh, there it is. Okay, so mod1.py. Now that our function names have changed, I'm going to say mod function, right? Then we're going to say in main program body and mod1 dot mod2, right? Just to give you an example, a complete example of how things work. And we're going to save and run this whole process, and now it is, right? So when I said import module 1, what did it do? It looked, or it finds the .py file, in mod1.py file in my current directory, which it found. Then it compiles it and created .py.c file, and then it actually runs the module, right? So 3 steps to when you say import. When you ran it, it prints in main body of the module, right? That's outside here, so it ran it. So I didn't even call it, I just said import, and it went through its 3 processes, and it runs that. Then we came over along to our main program and executed the rest of our main program. So it said print in main file, then it prints that statement. Then we called function mod1, and it does that. Then in main main body program, it did that, and then we called function 2, and I think I may have forgot to do that. So let's update this. Right, save this, and we come back and run this. Whoops, I meant to run the whole program. All right, run that. So now when I said mod function 2, it actually says in function 2 of the module. So I hope that makes sense again. Also, let's talk about our other way of importing. So I could also actually say from, if I didn't want to import all these modules, right? So by default, if you just say import module 1, you are actually importing all methods and objects that are available in the module. But I could just specify a single one, so I can say from mod1 and import mod1, and I can just say import let's just say mod function 3. Okay, so I'm only gonna import one module. Now if I run this, it should throw me an error saying that, well, mod1.module function 1 doesn't exist, or it's not defined, because we specifically said I only want to import one function and not all the others. So if I actually replace this with 3 and delete this, I run that program. Whoops, I forgot one more thing. So since we are actually now importing a specific method from our module, we don't need to have this the syntax of using module.method or our data object.function. We can just simply, since we're importing a specific method, we can remove that and call the method directly. So if we run this, that will work. So now we imported a specific method from the module. The module is executed, so it says in the main body of the module. Then the main program, we call the module or the method from the module itself, and then rest of the program. So I hope all that makes sense and brings it back a full circle. That our module can be more than just a single function. It could be multiple functions. You could import all or specific ones. How when you say import, the 3 steps that take place, which is find the file, whether it's the .py file or the bytecode file which is compiled, execute compile if it's an older file, and then execute the module itself before you run the rest of the program. So I hope that all comes back and makes a full circle. Okay, so that's it for our case study now. Now also let's take a look at the packages part of this whole series. So we started with modules and packages. We haven't looked at packages at all. Let's touch base on packages real quick.